Hey, everybody. Welcome to the HamptonRoads.net users group. I'm Kevin Griffin. I'm joined by my cohort, Drew.
Good evening.
How you doing? And our very special guest tonight, Mr. David Giard. David, how are you on this lovely evening? It's not lovely here in Norfolk, Virginia, where we are. So hopefully it's lovely where you are.
It was 97 degrees in Chicago today.
Ouch.
It is
So
97
not windy?
right now in the evening.
Any rain? Is it
I
sun, like
call it the
sun hot
sunshine.
or like overcast hot?
No, it's nice. It's a beautiful day. I went
Okay.
out for a long bike ride along the lake. I have no complaints.
I love seeing your bike riding photos on the Facebooks.
Thanks.
It's like, oh, look at David just out there enjoying life. I'm sitting here with my kids yelling in the background, and like, I live vicariously through David.
That's what I'm here for.
So we broadcast same time every month, every second Tuesday. We have not officially gone back in person because germs, and also it is really hard to find a venue, like a consistent venue that we can rely on for the future. Like our venue where Drew works is just kind of up in limbo, and we're not sure what's going to happen there. So we haven't come back in person yet for that reason. But we, taking advantage of the COVID to get amazing virtual speakers like David. So Seth, I see Seth in the chat. Seth, you want to come to the user group and teach us about some machine learning goodness and all that cool stuff? I mean, you popped in the chat, so I have to talk to you now. So
I still remember that code stack where we all first met Seth.
Oh my gosh.
He was doing that, talking about something called machine learning. Like, what is that? Machine learning.
It's yes, Seth, it is virtual. For you, it's virtual. Yeah,
We're all virtual.
totally is virtual. So you say code stock, but I've been to like 13 code stocks. So I've lost track of which code stock is the one Seth was at. Yeah. Like I remember, we're going to tangent. Like code stock has changed venues so many times. Like, well, which venue was it at the time that we're talking about? All right. We should get this party started because we are witnessing the world premiere of David Giard's newest talk. It's better than Top Gun Maverick, I'm told. That's what the reviews say. This is the world premiere of Blood, Sweat, and Code Reviews. David, I'm just going to turn it over to you, let you do your own introductions. And if anyone out in chat land has a question, drop it into the chat. David will signal to me when he's ready to answer some questions. But David, this is all you.
Thanks, Tim. It's great to be here. I remember when we first met in Tennessee somewhere. I remember when we became MVPs on the same day. I remember when we joined Ineta on the same day.
Oh my gosh. We have so much history.
We have a lot of shared history.
We're like technology brothers.
We're technology friends. I'm learning StreamYard. Give me a second.
All right.
Let's see. Hey, I want. And then this.
You're good. All You're right. Live to the world.
Let us talk about. Oh, what happened? There we go. Let's talk about code reviews. This is me. My name is David. I work for Microsoft. This is Jack, not his real name. Jack is a software developer. He was working on a feature, spent a week on it, tested it, made sure it did what it was supposed to do, checked his code into source control, merged it with a main branch. Shortly afterwards, it went out to production. Everything was great until a few weeks later when somebody found a bug in Jack's code and tweeted about it. And this was retweeted a bunch of times until it got back to Jack's boss, who said, hey, fix this bug. And Jack did. He fixed it, merged that fixed code into main, and everything was good after that. After a few weeks, took a little bit of time because the code had changed since then, but it's all good. This is Joe. Joe was building a feature. He's a software developer. Spent about a week on it, tested it, make sure it was right. But before he merged it with main, he submitted a pull request, and a reviewer looked at it and validated that it was good and actually found the bug, sent it back to Joe and said, hey, I found this bug, fix it. So Joe was able to fix that code a lot sooner submitted again. It got merged with main. It went out, and there were no bugs to be found. Everything was really good. The real difference between Joe and Jack's code is that that bug was found a lot sooner. And when things are found sooner, generally they tend to be easier and cheaper to fix, easier to merge code because the code hasn't changed a lot in between. And this is one of the advantages of code reviews. And that's what I want to talk about today. I want to talk about code reviews. I'll start with a couple of definitions, and I'll talk about what are the advantages of code reviews. And then what are the challenges? There's obviously a cost to code reviews. The most obvious one is the time and the effort to put into it. And we need to evaluate, is the cost worth the benefits? Most of the time, I think it is. And then of those costs and of those challenges, which of those can we address? Which of them are just kind of built into the system? Like the time. We have to put time into it. But there's some things that we can address. We can just make it better. And I'll talk a little about that because there's different things that different people in the code review process can do. And I'll finish up by pointing to a few more resources that you can look at that'll help you after this talk is done. All right, I said I want to start with some definitions. And the reason I have this is because I often use these words interchangeably, even though they're not the same. When you're writing software and you're changing software, that set of changes, the files that you changed and the lines of code that you changed, that is your change set. It's the software that you've changed at a given time. It's kind of a unit of change. A documentation of that is the change list. It's the code that changed and the reason why you changed, what it's expected to do after it's done. That is what we call a change list. A pull request is a request to take changed software and merge it with the main branch. We're asking to say, please take this software and merge it back into the main branch so it can get added to the rest of the code. And included with that pull request will be not only the changed software, but also that change list, the description of what has changed. So you'll see these three things are tightly related. And forgive me if I sometimes just use them interchangeably. They're not exactly the same, but they're close enough that I will say that ahead of time. All right, so a code review, these are the parties in a code review. There's the code author, the person that's actually making that change, writing code, fixing a bug, adding a new feature, whatever it is. And there's a code reviewer, the gatekeeper, who is looking at that change, making sure that it is good enough to be merged with the main branch. Here's a little animation of the process. Code author makes a change, submits a pull request. That's the change code and a description of that change code. The code reviewer looks at it, compiles it, looks at the code, verifies that it's good enough. If it's not good enough, then they will create a list of issues and send it back to the code author and say, here are some reasons why I cannot yet merge this code with the main branch. And the code author has to address those. Maybe fix those issues in code, or maybe explain why they're not issues, whatever it is. And then once those issues are addressed, send that back to the code reviewer again. And this process can go on multiple times back and forth until the code reviewer decides, yes, this is good enough. I approve these changes. Now it can be merged with the main branch of our code. And most DevOps systems like Azure DevOps or GitHub, they will have a process to enforce this, to say nothing get merged into main until the code reviewer has approved it. All right. So why do we do this? Well, there's a few reasons why. We want to validate the code, we want to share knowledge, increase code ownership. Let me just go into these one at a time here. Validating the code is probably the number one reason why we think about code reviews. When we think about validation, usually what we're thinking about is, does the code do what it's supposed to do? That's from the outside in perspective. The requirement was to build a feature or fix a bug. Did we fix that bug? Did we build the feature? Does this function if I add, put in these inputs, are the outputs expected? And that's at a minimum what this thing should do. But there are internal things, just looking at the code to say, is it good enough? For example, if the team has some guidelines with things on naming conventions or structures of directory, are we following those? Does the code actually meet those? If it doesn't, maybe we shouldn't approve those. Maybe we should send it back to the author to refactor it in some way. The code may be good in and of itself, but it may cause problems elsewhere. Maybe it uses too many resources or locks things. Maybe there's side effects to the code. Anything that's a potential problem, maybe not a problem with the code itself. And they're also, can the code be improved? Can it be refactored to make it more readable? Can it be more efficient? Can it be faster? So even if it does exactly what it's supposed to do, there are some reasons why we want internally that we would want to validate. So that's one big purpose of a code review, probably the most obvious one. But another one is just to share knowledge among the team. As a reviewer, if I'm looking at your code, then I get a better understanding of the business problem that you're trying to solve, the components you're working on, maybe the language that you're using, and the tools that you're using. This is the problem. As a software developer, I've been in literally hundreds of meetings where I was run over by a hypothetical bus. Every developer, has a bus, a hypothetical bus that's circling the city. And when you go into a meeting, they say, what happens if Dave gets hit by this bus? And if all the knowledge about this component and the subsystem is all inside of my head, well, the team is screwed. But if we're sharing that knowledge, if multiple people know about it, then that's a way of insurance against the bus. And code reviews are a good way to share that knowledge. Share knowledge about the business rules, but also about the technology and the tools. We can learn a lot by reviewing someone else's code. Also, the feedback you get back from the reviewer, the author can learn a lot from that as well. Code reviews are a good way to make engineering, but more specifically to raise engineering decisions that haven't been made. Ideally, what you'll do is you'll have an architecture design session before you start writing the code, and you'll decide things like, what's our testing strategy? How are we going to access data? What are our coding standards? But sometimes, if those haven't been clearly defined ahead of time, then they become a point of issue during a code review, because we see that people are violating them a lot, or they're ambiguous. Then we can use the code review to feed back into these coding guidelines. Of course, we want to address the weaknesses of the code if it's not doing what it's supposed to do, if it's not efficient, but also addressing weaknesses in developers. Sometimes a code review can reveal that a developer isn't aware of a particular algorithm or a particular tool or a particular design pattern. And that can become obvious. Why did you do it this way when a Lambda would be much easier to use, or using this third-party tool would be much easier to use? Probably because they're not aware of it. It's a good way of educating them on that. And then, of course, the long-term benefits, I kind of alluded that to in the parable I told earlier about Joe and Jack, is that if we're catching these things earlier, the code review is really designed to catch problems sooner rather than later, then we don't have to spend time later on doing rework. Rework long after the fact is a lot more expensive than doing it right after when everything's fresh in your mind. We have fewer issues with integration testing, less problems with customers, end user customers. We don't have to deal with support calls. Just the whole idea that we're going to catch these problems sooner rather than later, there's a huge benefit to that. So these are, I think, you'll agree, there are definitely some big advantages to code reviews. But I said earlier that there are costs to this. And the big one is time and effort. And we don't have unlimited amounts of time and effort. Code reviews do take time. There's just no way around that. And they also take some concentration by both the reviewer and by the author as we sort of play this ping pong back and forth. And we don't have unlimited stamina to focus and read code and understand, come up with these things here. So that's a big cost of it. Another thing is that sometimes if you've got multiple features that are dependent upon one another, if you have a feature B is dependent upon feature A, then we have to implement feature A before we implement feature B. And that code review could be blocking feature A because the code reviewer has issues with it. It's still in this back and forth process between the author and the reviewer. That can be an issue. Communication is a big issue. What I say to you may not necessarily be what you hear from me. We're going to talk a lot about that in this presentation. How we can improve that communication. Part of the problem with communication is different people have different opinions. We're coming at each other from different areas, and we may have very strong opinions about the way things are done. And sometimes, even though we have different opinions, sometimes we're both right. There is very little dogma in software development. There are often multiple right ways to do a thing. And if we're clashing on this, we might both be right. And even though one of us might be more right than the other, that doesn't mean the other person is wrong. And finally, there's just a cultural thing that I think in our society and in our educational system, we value individual accomplishments over collaboration. This is the way that our education system works is, what did you do? What was your contribution to this project? Whereas a good code review process expects us to let go of that a little bit. We want to be collaborating. We shouldn't be seeing these things as this code review process as a conflict between the author and the reviewer. We are all driving towards the same goal. We don't want to take personally what we're doing and take too much ownership of what our code is. All right. Some of these can't be addressed. We're still going to take time, but some of them can. We'll talk about those. Here's some challenges specifically to the reviewer. A lot of us pointing out errors is just it just feels funny. This code is wrong. It feels like we're criticizing someone else, and a lot of us are not really comfortable doing that. But that's our job as a reviewer, to point out potential problems as the code reviewer. We need to get past that. The code author, of course, knows the code better than anyone else. They wrote the code, and getting over that and saying, I know enough to understand what their issues are. I need to document those issues. These are just challenges that can face a reviewer. The code author, this first one is a big one. We as software developers so often start to identify with the code. We personalize the code. We think, this code is an extension of myself. I wrote it. I put blood, sweat, and tears into it. If you're criticizing that, you're criticizing me. Something that we really need to let go of. And the other is that sometimes bad managers will criticize you for too many issues that are found in your code review process. The purpose of the code review process is to raise those issues. And so that can be uncomfortable. And we need to understand that we're all in this together, that we really want the reviewer to catch these problems. We don't want them to go on and have the customer catch them. So these are just challenges. They're all challenges. They can be a problem. That's the cost of a code review. Can we improve them? And the answer is yes. There are some things that we can do to improve them. The code reviewer. Let's start with the code reviewer. Remember, there are two parties: there's the author and the reviewer. We're going to start with the reviewer, person that's looking at the code. What can they do to make this more effective? All right, that's good. First thing, start the review right away. Start it while the code is fresh in the author's mind. That way that any issues that I find, if I send it back to the author won't have to readjust and remember where they were when they wrote the code. This will also make the entire process go faster, because the sooner we can get this through, the sooner we can try to merge the code. And the sooner we merge the code, the fewer other changes there'll be in the code, which will make it a lot easier to merge. So anything we can do to accelerate that process is a good thing. Reviewers should start at the high level and work to the low level. What I mean by that is, at the high level are things like the architecture of the code, what are the classes that we're using, what are the interfaces that we're using, what's the separation of concerns. These are all high level decisions. Low level is the actual implementation of the code, the lines of code that you've written. If we start at the low level, we may miss some of the high level things. But if we start at the high level, then often fixing the high level things will automatically fix the low level things. So as a code reviewer, you really want to start at the high level, skip the details, get to those later, and focus on that. Work high to low. Be a lot more efficient. Use the computer whenever possible. A reviewer doesn't have to do everything themselves. We've got tools, of course, you want to pull the code down, compile it, validate that it compiles. If the code has automated unit tests, run those tests. There are tools that will check the formatting of things. A lot of styling tools will validate that your code matches the naming conventions and the header comments and whatever styling that you're requiring on here. There are tools that allow that. Start with that. That's boring, mundane stuff. It's time consuming if you try to do it manually. Take advantage of the technology to do this. It'll probably do a better job than you anyway. Create a style guide. Oops. Create a style guide ahead of time. This is defines things like naming conventions, structure of code, directory structure, class names. You can start with your own, or you can start with borrow one from somebody else and modify it. I've got a link here to Google has one, and I've very often taken this and just looked at it, and usually don't use it exactly as is, but it has one for multiple languages, and you can pick and choose the parts of it that you want. It won't be perfect. What you'll discover is that over time it'll evolve. You'll realize that there are gaps in it. There are things that aren't covered in the style guide, but you can add to those as time moves on. And well, this makes code reviews go a lot simpler, because a lot of these times we're arguing over tabs versus spaces, or camel case versus Pascal case. You can just point to the style guide and say, this is what we decided on originally. This is what we're going to do. The argument is done. It's one less argument to have. As a code reviewer, one of the really nice things you do is to add code examples into your code. Be generous with those code examples. Often the author might not be familiar with something that you're suggesting. If you're saying, I want to use this particular design pattern, and they're not familiar with it, a short example of what their design, the implementation of that design pattern will really go a long way, or a link to an example will help them out and make it really more efficient. This should really be things that will make the code more efficient. Like, for example, reduce the number of lines of code. I wouldn't overdo this. You don't want to come across as that suggesting the author doesn't know how to write the code, but a little nudge in the right direction with an example is a really nice thing for an author. It can enhance your comments in the review. This is a big one. I talked about this earlier, that sometimes we as code authors, we tend to internalize our code. We take any criticism of our code as a personal attack on ourselves. And even though I as a reviewer don't mean it that way, it can come across that way. Just be cognizant of that. Avoid saying you. Don't say things like, you misspelled this variable name. Say this variable name was misspelled, or use we in replace of use. Formulate things as requests rather than commands, rather than saying, split this into 2 classes. Say, this would be better if it were split into 2 classes. Whenever you have a change like that, like splitting into multiple classes, point to principles. Don't just say, it's my opinion this should be multiple classes. Say things like, this class does more than one thing, which violates the single responsibility principle, therefore should be split into multiple classes. If you point to, people can always argue your opinion, but if you point to principles that we all agree on, then that's much less, they're much less likely to argue with you on that. It's much more compelling. And then finally, I almost never say this, but sometimes using the passive voice can be gentler. So if rather than saying, change this code, you can say, this code should be changed, or this code can be changed. It's a softer approach than use this. In most writing, I say, don't use the passive voice, use the active voice. But if you want to soften things, sometimes that's a good way to do it. All right, this is something I just read about recently, and I've been using on my last few code reviews here, is there's different types of feedback you can give in a code review. And if you prefix each of your comments with something like issue, suggestion, question, nit, thought, chore, praise, this isn't an exhaustive list. You can create your own list. But if you do that, then it gives an idea of what exactly that comment refers to. So for example, the issue refers to a specific problem. Describe the problem, and then you would pair that with a suggestion. An example of issue is this violates, this code does multiple things. It violates a single responsibility principle. Suggestion, split it up into multiple classes. A question is a potential concern. It may or may not be relevant. You just want some clarification on that. So the address of that might be just to answer the question as opposed to changing the code. A nit is a really small change that's necessary, but trivial. So for example, if a string is misspelled, for example, very simple to fix that, has to get done. It's nitpicking, but it still has to get done. Thought might not be relevant to this code review, might not require any action at all. It's just an idea. I'm going to throw this out and say, have you thought about doing it this way, using this third-party tool, for example? Chore is another simple task that has to be done, a little bit more than a nit. And then praise, I really like. I never used to do this, and just recently started to. Code reviews, we always think of them as ways of pointing out criticisms or things that are wrong in the code. If you see something that's really clever, point it out. Add that into a code comment. It can go a long way because we're a collaborative and we want to build that relationship between the author and the reviewer. And praise, sincere praise, is one way to really well do that. So here's some example here. Issues and suggestions, they should go together here. I'll make this slide deck available at the end if you want to just download it here. Things like this. And praise sincerely. Insincere praise doesn't help at all. Great job. This is awesome. But saying this is, this particular algorithm was really clever, and I hadn't thought about it. Pick and choose where you want to see it. Sincere praise. I'm a big fan of that just in real life. And just in the last few months, I started applying it to code reviews, something that I read an article on that. It just resonated with me. All right, let's see, another one here. Repeating feedback. Code reviews can get really long. Generally, if someone makes a mistake, it's not uncommon for that same mistake to be repeated multiple times. You don't need to repeat a long comment multiple times. You can just write it one time and say, see my comment above. It's a much more efficient way of communicating. The scope of the code review. Just like scope creep can be a problem in requirements when building software, scope creep can also be a problem in a code review. As much as possible, you want to avoid feedback on lines that are not part of the change set. So invariably, you will find problems in the code that had nothing to do with the code that the author just changed. Resist the temptation to create issues on that. There are a few exceptions. If it's a really trivial change and you don't have a whole lot of other feedback, it's probably okay. Look, here's a spelling error on line 27, even though you changed line 35. It's quick to fix, and I don't have a whole lot of other things here. Why not? Still think about it. And then also sometimes a change on one line can affect another line. So I think one example of that would be if you've refactored a method and now the name of the method doesn't really describe what the method does. The name of the method didn't change, but maybe it should have changed. So things like that. But generally speaking, think about the scope of the review and narrow your scope to be only those things that are that have to do with the code that you're reviewing, the code that you've been asked to review. If you don't do so, it can extend that code review process a lot longer than it needs to be. Stalemates inevitably happen. I believe one thing, you believe something else, and we argue over it, and this ping pong happens back and forth quite a bit. We are, I've submitted issues. You've said this isn't an issue. I say it is. You say it's not, and we get stuck in this stalemate. No progress no progress happens. The code review gets stuck. There's tension between the author and the reviewer, which destroys this whole collaboration thing that I've already stated should be a goal. When you discover this happening, first step should be to discuss it. Either walk over to the person's desk, set up a Zoom meeting or a Teams meeting, and just have an open discussion. What are the issues? Why are we having this? Why are we not agreeing on this? Code reviews typically happen. That communication typically happens written communication. Written communication is fine, but it's imperfect. We miss a lot of context when we do so. So just having a face-to-face conversation can often resolve that. If it doesn't resolve it, then maybe we need to have a design review, because a lot of times these discussions should have been should have taken place during an architectural design session. And maybe we did take a step back and say, what is the architecture we're building here? Maybe get a third party involved, maybe bring an architect in to mitigate this, and just decide what exactly our goals are and what are we designing towards. And then consider conceding. Consider that, is the other person's solution acceptable? And sometimes that's okay. It's not every hill is worth dying on. And so, as I said earlier, there are multiple right answers to a lot of problems in software development. There's very little dogma. There's very little times when you say, this is the way to do it. This is the only way to do it. You may believe strongly that your solution is more right than theirs. That doesn't mean their solution is wrong. So if it's going to free things up, think about conceding. And if you hit a blocker and you just can't get past it, escalate. Bring in a project manager, bring in an architect, bring in somebody with authority to actually make the decision. Don't let this thing go on for weeks. This sounds silly that your goal should be to improve your code. Of course, your goal should be to improve your code, but the reason this is in here is because some people see the goal is to make the code perfect. As a reviewer, I want that code to be perfect before it gets merged with main, because that's the kind of code I want. It's perfect code. And sometimes that's not necessary. I've heard this described as bring the code up by a letter grade. So if you get code that's really bad, maybe it's a D, maybe strive to bring it to a C. If it's a C, strive to bring it to a B. And what will happen often is that if you can bring it up a little bit and improve it, then the next time it'll come in as a C because of the feedback that you've given, and then you can move from a C to a B. The next time it'll come as a B, and you'll be able to move it from a B to an A. Think about what are the really, if you've got some code that really has a lot of issues, which are the ones that are blocking? Which are the ones that absolutely cannot go into production and get merged with main? Not everything meets that criteria. And having a code review going on for weeks because there are 100 different issues can really be a problem. And it can often be a greater problem than having a little bit of imperfect code in your code base that can be improved later on, deferring those problems. If it is something, by the way, if it is something with hundreds of issues, maybe the code review is trying to review too much. Maybe the first step should be send it back and say, let's split this up into multiple change sets and therefore multiple pull requests. And let's review those multiple times, because something with hundreds of changes in it is going to be a challenge to fix and a challenge to review. All right. So that's my review. Think about the comments you're giving. Give good, actionable comments, combine similar ones. But I think number one is don't make it personal. Think about the collaboration that you have with the code author, and this is what you want to work towards. You're not here to attack them. You guys both have the same goal. All right, I'm going to pause there for any questions. So I've been talking a while.
Not necessarily any questions, just chit chat.
You know what, chit chat. All right, cool.
Just chit chat. So
I should move this over to another monitor. All right. Let's talk about the reviewer. I'm sorry, the code author. So that was the reviewer. What can the code author do to make the code review more productive? Number one, test, write automated tests, do manual tests, validate the code before you send it off to there. Just like the reviewer should use the computer, the code author should also be using the computer. There's a compiler, there's a linter, there's a framework for running automated tests. Take advantage of that. Automate these things before you check your code in, before you generate the pull request. Let the computer do the mundane stuff. And I think one hugely important thing is to review your own code first. Put yourself in the shoes of the code reviewer and think about the things that they are looking for and review it. Validate that it does what it's supposed to do. Is it readable? Is it efficient? Is it structured in a way that makes sense? Think about the things, if you were reading your code for the first time, what sort of things would jump out at you? Taking a few minutes to do that often will reveal things that weren't obvious as you were writing the code. When I was talking about definitions, I mentioned the difference between a change set and a change list. A change list is a description of all the changes. Be explicit about that. Be clear about what you change, the purpose of that change, what the inputs and outputs are, what should be expected. When you get feedback from the reviewer and you've addressed that feedback either by changing the code or by just answering their questions, communicate that as clearly as possible. The better you can communicate, the smoother this thing will go. Just take a second to step back and make sure that you're being explicit as to what you're doing. If there's anything that's missing, solicit that information. Ask that. If somebody says, hey, this isn't clear, ask that question. Why isn't that clear? What about it isn't clear? And sometimes that communication can happen right inside of the code. By refactoring your code to make it more readable, having method names that are meaningful, splitting out larger sections into their own methods, that can eliminate a lot of confusion. A lot of times, issues pop up because the reviewer doesn't understand the code. And maybe when that happens, the issue is, even if the code is right, the issue could be that you didn't make it readable enough. This is a learning opportunity for you as the author to say, oh, you know what? Someone that didn't write this code doesn't understand it. I need to look at it from their point of view. Simplifying things. This is a big one. Trying to do too much with a single pull request is self-defeating. It makes it really hard to review a large code review that changed thousands of lines of code. If you find yourself doing that, split it up into multiple change set, multiple pull requests, narrow the scope of each one. Each one should be, just like each class should only be doing one and only one thing. Each change request, each pull request should really only be addressing one feature or one bug fixed. One common problem is that as I'm making functional changes to the code, maybe I want to refactor it to do non-functional changes, maybe changing the indentation, for example, or changing from tabs to spaces, whatever. The problem with that is that often those things might affect every single line of code, and any kind of code comparison tool make it really hard to see which lines actually had functional changes in there if everything changes because I changed it in indenting structure. Oh, I didn't change the slide on that. Where am I? Oh, wait a minute. Hang on. Sorry about this. That's a quick, keep it simple. Did that. Stay cool. Easy boy, stay cool boy, get cool boy. Don't take it personally. This is, the reviewer is trying to do you a favor. The reviewer is trying to make your code better, which is exactly the same goal that you have. And you may run into reviewers that are not great communicators. You may run into reviewers that didn't see my earlier slide, and they're being attacking, and they're saying you as if they're pointing their finger in your face. You made this mistake. When that happens, look past the delivery and look at the message. What is it that they're trying to say? What's the issue with the code that they're trying to communicate here? Because that's really what it's all about. And respond graciously to that. Understand what that is. Correct the things that you can correct. And sometimes, the reviewer is just wrong, and that's okay. The reviewers are human; they make mistakes, and you can point that out. You can point that out graciously, but also recognize that if the reviewer is wrong, then maybe that there was a communication issue on your part. Maybe your code wasn't self-documenting enough, and that is what led to their incorrect assumptions. And maybe that's an opportunity for you to make your code more readable. Responding quickly, this is the flip side of starting soon. The faster you can respond, the more fresh in the mind of the reviewer will be the issues that they raise. You can get back to them soon. They don't have to get themselves back into the mindset of what the code did and figuring out where they were at that point. And the faster the whole process will go, the faster the whole process goes, easier it'll be to merge because there'll be a few other merges to the code in the meantime. Obviously, this isn't always possible. You can't just drop everything right away because you're probably working on something else. But just be cognizant of this, that the more quickly you can respond to the issues that come back, the faster this process will go, the easier it'll be for everyone else. This is some advice I read recently, that if the reviewer has if you and the reviewer disagree on something, but you're both right, generally the reviewer should just concede, unless it's a major rewrite. That it's going to be a refactor that's going to take days to do. Generally, it's easier for the author to concede than it is for the reviewer to concede. Just a general rule of thumb. You may or may not agree with that, but that is a suggestion for this. Okay, here's some of the best practices of code author. Review your code first. Think about try to put yourself in the mind of the reviewer. Create smaller change sets that are simpler to review. If you've got lots of things to change, split them up into multiple pull requests. Make your code as readable as possible. Make your comments as readable as possible. Your change list as readable as possible. Make your responses to the issues as readable as possible. Just good communication. And I think this last one is probably the biggest one. Don't take it personally. Don't, we as code authors, we take great pride in what we do. It's suggestions for improving our code are not personal attacks on us. So resist that urge, even if it feels that way. And then together, the shorter you can make this review process, the better you are. And there's a lot of ways to do that. Communicating better, smaller research sets, keeping the communication respectful without personal attacks or without taking everything personal. This is probably the number one lesson of this, is that we're all working towards the same goal. I think when I first got into this business, there always seemed to be this antagonistic view between the code author and the code reviewer. The reviewers or the testers, somebody else, they were there to catch problems, to find problems, and that's not the mindset we want to have. We all have the same goal here. We want to communicate, and if they're catching things, they're actually doing us a favor by doing that. And I had, just as a bonus for you managers out there, here's a few tips here as well. Rotate who reviews whose code. It should always be someone that wasn't involved in writing the code. But also, if Mary is always reviewing Kevin's code, then we're not getting a chance for other people on the team besides Mary to see Kevin's code. We want other people to get visibility into that. We want to see other people bring their experience in to get feedback to Kevin, so we can benefit from that. So rotating people are doing that. Reviewers should also be authors. Make sure everyone is both authoring code and reviewing code. These aren't just discrete roles. These are just roles that at a given time. Just about any application lifecycle management tool like Azure DevOps or GitHub has the ability to require a code review just by checking a box. Sometimes you require multiple code reviews. Multiple people, or you could have multiple people that have to approve it before doing that. I was on a project recently where we were working with a customer, and we had a requirement that said one person from my company had to review the code, and one person from the customer also had to review the code. That was a policy that we set up, and that guaranteed that the customer always had somebody looking at the code and make sure they were comfortable with it. And then just fostering this culture of teamwork. If you're criticizing people for bugs that are found in their code, or for code reviews that come back with issues, then you're not building this collaborative process. Code reviews work best when we're all working toward the same goal. I am just about done here. I have a few links here. The only one you really need is this one right here. This is these slides that I just showed you right here, because of course, if you click on that, you'll have the rest of the slide as well. But I'll go through them. This is a series of articles that I wrote that are more or less the contents of this presentation. And then a couple of really good articles I read that contribute to these thoughts that I added to this. There's a two-part one. This is more the first one. They're all by a fellow named I think Michael Lynch, and first one is geared toward code reviewers, and the third one is geared toward code authors, and then a couple other ones. There's a Pluralsight document on code reviews, and this convention comments. This is where I got the idea about putting the. Let's bring this over here. Label, subject, decoration, some more detail about that. Adding praise, nitpicks. There's a few more in here that I didn't add here. Prefixing ones, which I just thought was a really good idea that came out of this guy's article. This is me. You can get to contact me either on Twitter or via email. And also, if you'd like, it'd be nice if you looked at these 2 TV shows I have on YouTube. Some people in the audience have actually been on these shows, so take a look at that. And that's what I have. Thanks very much.
All righty. Well, friends, there you go. Now is the time that you should really drop your questions into the chat for David. There was a conversation a little bit earlier. We didn't really touch on it from Sean. Do you think that there's a point where the reviewer coder cycle is better converted into like mob programming?
Into mob programming?
Yeah, mob programming. You're familiar with mob programming, aren't you?
Just define that for me.
So mob programming, you just throw all the developers in a single room with a keyboard, and they take turns coding, and then everyone else yells at them. I'm being a little facetious, but that's kind of the idea.
I've never done that.
The team is all coding at the same time.
I have not done that. Does anyone here have experience with that?
I don't.
I've done pair programming, and I guess
when
I first did pair programming, there was this mental resistance that, in my mind, I've seen in other people, is that, oh, how could it be more efficient? Isn't it half as efficient? You have 2 people doing the same thing. And then I overcame that, and now I believe that pair programming is actually more efficient. And so, but I'm having that same mental block right now. Where you just described mob programming. It seems less efficient because not only are you spending a lot of people's time, but it's hard to communicate. Mobs don't communicate as well as just 2 people.
Well, it's pair programming with multiple pairs. So all the pairs are in the same room.
But they're all working on the same.
There was a team.
This might just be my, as I said, this might just be my mental block. I don't know.
There was a team out there and like specialized in mob programming is how their workflow went.
I have no experience in that, so I can't. This is just my gut reaction to it.
Yeah. I always find with pair programming, I love pair programming. I think pair programming is really good in spurts, like very specific use cases. Like there's still something to be said for the developer going in the corner and just working on something. But then there are sometimes when your head hits the wall and you need that person next to you to help you get over some humps. So I love a little bit of both, and sometimes I just don't want someone like commenting on my code as I'm going through.
Yeah, I see Sean asked about that's where the question came from, is pair programming or mob programming. And pair programming, I am a fan of that. I don't think that relieves us of the responsibilities or the advantages of a code review process. I think even if you're doing pair programming, you still need another set of eyes on it. Because typically, when I've done pair programming, often it's one of us typing and the other one thinking, kind of thing. It's there's still an advantage to having another set of eyes to review it before it gets merged in. What happens with pair programming, I think, is I and my partner tend to be thinking as one, and we're not as good about thinking outside of the box or looking at edge cases, whereas the reviewer is independent, has no ownership of the code, gets a different perspective.
There was a really cool one of the first presentations I ever saw on pair programming, and this was a Richmond Code Camp back in 2007.
Dang, you're old.
I am old. Now, in my defense, I was only a year out of college. It was 2007, 2008. I don't remember quite when, but it was two gentlemen from Lycotic, which is a company based up in DC, and they did pair programming with 2 keyboards. So one monitor, they would both plug a keyboard into the computer, and I actually think they both had mice. I don't remember exactly how it went, but one would go, and then the other one would take over, and they would go back and forth, and that's how they would rapidly develop a lot of their software. Is enhanced.
And they did that on stage.
They were doing it on stage, yeah. It was really cool. Now you could basically do that with Live Share, right? And all these pair programming tools. Very cool. All right, friends, out in the live stream space, let us know if you have any other questions. David, we'll take this recording and polish it up a little, take your links and make sure those are all posted so folks can check this out afterwards. And now that you've gone through and done it once, now you can go through and perfect this talk now and give it to everyone else. But we're really happy that we were the world premiere.
From now on, anybody asks me, where did you get this talk first? I have to say.
And it was when you started the talk and you were showing pictures of me, I'm like, oh man, I forgot. I lost count of how many pictures of me that David Giard's taken because we've known each other for so long. Yeah. Okay, well, thank you everyone out there for watching. Thank you, David, for hanging out with us today. Drew, thank you for hanging out as well. We'll be back next month with Joe Kunk. I'm not sure what Joe's talking about, but I'll have to follow up with him. But we're always looking for presenters. So if you're interested in speaking virtually to our group, let me know. Just hit me up on Twitter at @1KevGriff, and I would love to chat with you, and we can see if we can get you on the schedule. But thank you everyone for hanging out. We'll see you next month.